Hello everyone, I'm just making another video to help scaffold your number talks. I think it's really important to follow along with what I've got to say here as a beginning point. I'm hoping eventually that we don't need these videos. We've got the tools and the language to help us have these discussions in either on our table or as our class, and we can just go straight to a pack of cards and draw out a number. Okay, so I've got a really specific example. I have not randomly generated a number today. I've picked 43 as a number that I want to work on because it's a prime number, and I think the direction of our number talks needs to take a slightly different direction to if we're working with a composite number, perhaps. And there's some really interesting things that I can show you and get you to think about along this journey. So that's why I've made a separate video, just to give you a scaffold to work with prime numbers when they appear, because there's a lot of primes between 1 and 100. Okay, so the other things I really want you'll need a calculator, whatever form of that calculator you have, you'll need it today. And what I want is pen and paper in your hand, ready to go, ready to follow along with what I'm doing. So I'm going to jump behind the light board now, and we're going to talk about the number 43 and see where that takes us. Okay, so we're talking about the number 43 today. 43 is a prime number. I said that in the introduction. Instead of picking a number at random, I'm talking about a prime number today because I want to show you a way of working, give you that scaffold to work with primes. So let's start with some foundational type knowledge. And we should be looking at 43 and thinking about where is 43 on the number line. And I'm just putting my bookends, if you like, in here. I'm putting 50 in the middle. And then I just might jump back here and put 40. And I might say 43 is here. Okay, this is just a sketch. This is not to scale, but it helps me locate 43 on the number line. Okay, and it helps me with my next set of questions because I'm thinking about rounding 43. And I'm thinking the nearest 10, and 43 is going to be approximately equal to 40, because the distance between 40 and 43 is smaller than going towards 50. So there's my decisions, quick decisions, easy decisions. And we want to think about this number 43 to the nearest 100, and that's going to round down to 0, sorry. And the thinking here is the same sort of thinking. 43 is only 43, take away 43, we get to 0. On the other hand, we need to add 57 to get to 100. So always, and I think we've discussed this before, we make our decisions, find the middle, 5's in the middle, and think about it as a distance between the next hundreds. Okay, we need to round 43 down to 0 in this case. So this sort of setup helps us with the next set of questions, because I'm thinking other ways to write 43. Quite simple. 43 is equal to 40 plus 3. And that helped us with our decision making there before. And I like this one. 43 is equal to 20 plus 21. Those numbers, they're consecutive numbers, so that's interesting. And of course you can find other ways to write this. There's multiple ways you could do this. And so we've thought about 43 and creating another way to write this as the sum of. Okay, so we've in essence we've just used the addition sign here, and the other way I want to think about it is 43, writing 43 as a difference, and that could look like something like 50 subtract 7. Okay, because we thought about that work up here when we rounded to the nearest tens. So there's a way to quickly write this. And 43, we also thought about it when we're rounding to the nearest 100. We could write this as 100 subtract 57. Okay, now we've used the subtraction sign here. So the technical word here is a difference. So, and also a way to think about it is a distance. Okay, and by doing these things, we're sort of thinking about those concepts and learning those words. So I'm just going to clean the board and move on to the intermediate type skills. Okay, so we're on to some intermediate skills, and I might ask you to draw another quick sketch of a number line, and this time let's put 40 in, 41, 42, 43, and 44. We've just zoomed in on the number line, and this is a number that we're studying today, 43. It is prime. And so this is a really interesting thing. In our conversations about the next level of skills, we're often talking about factors. Now the factors of 43 are 43 is equal to 1 times 43. So in one way of thinking, this is one row of 43. And this is the only way we can construct 43. So the work on the factors is possibly not that interesting, all right? Because the job's done. But I pause there because there's a lot of interesting work to do. So what I want to do now is flip to multiples. And multiples are just thinking about creating a list of 43, multiples of 43. So we've got 43 in that list. We double it, so that's timesing by 2, so that's 86. And then we times by 3, and that is going to be 129. And we times by 4. Now here's my tip here. Timesing by 4 is just taking this number and doubling it. So that's going to be 160 plus 12, 172. And we're up to, let's do one more, times by 5. And this time I'm just going to bust out another move to help us with that. We're going to go 5 times 40 plus 3. Okay, so work that we did before is useful now. So I'm thinking about this as 5 times 4 is 20. Add another 0 on there to make it 200. 5 times 3 is 15. So they're going to add together to 215. Okay, and there's our list of multiples. And in some ways we could stop there. So I'm just going to clean the board because the real action is coming up next, and when we jump into some more advanced sort of questions and ways of thinking. Now when we get up to the advanced section, I really want you guys thinking about, say, two things. What is a square? And driven by the questions, what is a square of this number and what is a square root of this number? So we'll do that work now, and I've left the number line here for an important reason, because there's a really rich discussion that we can have when we're dealing with primes here. So let's answer these two questions if you like. So if we want to do the square of 43, we build a square of 43 times 43. Remember, these sides are all the same length. I'm going to do that move again. I'm going to think about this as 40 instead of 43. And I think about this as 40 plus 3. And I'm going to do the same thing on this side. So that's 40 and 3, and makes our multiplication easy. So 4 times 4 is 16. Put the 2 zeros on the end. 4 times 3 is 12. And put the 0 on the end. Now this is the same measurement here, same area if you like. And 3 times 3 is 9 down here. So we've got everything we need. A little bit of addition here. 1600 plus, I'm just going to add these two together in my head here. That's going to be 240, and I'll put the 9 on there because at the end of the day here, what are we looking at? We've got 1849. And just to complete this statement, 43 squared is equal to this number here. So good practice on those moves there, good discussion that we can have about doing that. And just as a way of checking, there's a little button on your calculator that says x squared. So you can actually put in 43, hit this button here, it'll put a little squared there, and hopefully we end up with the same number. Now we want to work on the square root of 43. Now in your calculator you have this button here, and you're welcome to find it right now and type in the square root of 43. You hit the button first, then put the numbers in under there, and that will work out to be 6.55, and you'll see numbers fill the screen. I've run out of room there, but just know that this is an irrational number. So those decimal places do not end, and they do not, there's no repeating sequence in there. So what your calculator screen has done is just rounded off the last digit to display it. So but let's do the other work that I've taught you, just to find another way to work this out. So I'm thinking about my square numbers. I've got 36 and 49. So that's 6 squared and that's 7 squared. And 43 is in here somewhere. Okay, that's the number we're studying. That's the number we're working on. And I know from here that the square root of 43 has to be 6 point something. I know this by just drawing out the number line here. And as a fraction, let's work that out now. And I'm thinking about the distance between those square numbers, and that is plus 13. So that becomes my denominator. And I'm thinking about the distance between 36 and 43. So that is plus 4 to 40, plus 3 is plus 7 to there. And as an approximation, that is roughly what the square root of 43 is as a fraction. Very rough. All right. And the interesting part about that, and what I want you to play with, is just thinking about those square numbers and how we come to that answer. If we've got 6 squared and we want to build 7 squared, we have to, if we're using counters here, we have to add 6 in here, 6 in there, and 1 in here. And if there's 36 here, 36 plus 2 lots of 6 is 12, plus 1 equals 49. So that'd be 49 counters there. And if we wanted 43, we would have to put 7 counters along the edge there, perhaps. All right. So that's how we got there. So just to double check, 6 squared is 36. So our square root of 43 will be approximately equal to, so I need to change the sign from an equal sign, 6. And to build the next square of 7, we needed 13 more counters. To create 43, we only used 7 of those counters. I'm going to show you a little bit more work on in the advanced section. We got to this really quickly. We decided that 43 was a prime number and the only factors were 1 and 43. So the square root is actually a very good tool for finding factors. And let's have a play around with this. Every number, including 43, can be squared. Turned into a square. Okay? It's easy with numbers like 36 and 49. Okay? So there's a little bit of a leap here in what you need to understand here, but it's very useful. So the square root of 43 times the square root of 43 is equal to 43. And if you don't believe me, use this button again on your calculator and type in the square root of 43 times the square root of 43. Now be very careful that this line doesn't extend, so you might need to press your cursor and get out of there, put the times sign and put it in again. Another way you could do this would be maybe use some brackets here and put the square root of 43 and square it. Okay? And in both cases the answer should pop out as 43. Okay? That's programmed into your computer, into your calculator. That's the way it works. So good little play around, but it really helps us with our discussion here because we're on the search for finding factors of 43. And if you understand this, it actually halves the amount of work that you need to do, right? We knew that the square root of 43 was as a nearest whole number was approximately 6. Okay, we're going to think about that as the whole number 6, and that's useful because really, if all I need to do to test this out, we don't have to do 1. We know 1's a factor. We could do 2, but we know 43 is an odd number, so we don't really need to test that. So 3, 4, 5, and 6 are the options worth trying. So we've generated a list of factors and we're thinking about how many times do these numbers go in evenly into 43. We know it's an odd number, so 6 won't go in and 4 won't go in. And another little test here is this 43 doesn't end in a 5 or a 0, so 5 won't go in, and we're only left with one option here worth trying. Okay, and that is, let's try, just be careful with these signs. That's not the square root sign, that's the sign for doing division. So we're going to see how many times 3 goes into 43. It goes in once, and we need to carry 1, so that's 13. 3 goes in there 4 times, remainder 1. Okay, so it doesn't go in evenly. All right, so this is a little test we can always do to check and find factors. All right, so just using some drawings here, we can, any number, we can square it. So what we're actually thinking about doing here is using the shorter side, and we're thinking about, are there other ways that we can perhaps create a rectangle of a different size here? And if we focus in on the shorter side, it's easier for us to work out the numbers. And if it goes in evenly, well, the larger factor just pops out on the other side. Okay, we get that up here, but in this case there's a remainder, so it doesn't go in evenly, so it can't be a factor. This is a final part of the video that I want to talk to you about. I think this is probably the most interesting part of this because we're here to bust a couple of things if we can, a couple of things that we're told perhaps, or what we learn about prime numbers. We can only make them as one row of 43. And I did that here for you and it's a great way to think about primes. But this little part of the video might really open up your mind to thinking about primes differently. Okay, now first thing, 43 is located next to 42, and 42 is a multiple of 6. Okay, that's important because primes generally are located either side of a multiple of 6. Now it so happens that 41 is prime too. So these are twins. Okay, they're located either side of a multiple of 6. Okay, the difference between these two numbers is 2. Okay, that's important. And there are other twin primes. 5 and 7 are twin primes, for example. I'm just going to sketch that here. We've got 5, 6, 7. That's probably the easiest one to work out. They're located either side of a multiple of 6. 6 times 1. Okay, so again, some interesting work there, and just seeing those things, it's as far as that work goes. But the drawing and rearranging of primes is something I find really interesting. And we talked about primes being next to a multiple of 6, but I drew this number line for a reason. These primes are also next to multiples of 4. Okay, so 40 is a multiple of 4. And 44 is a multiple of 4. So there's two sets of the, don't get worried about the algebra here, we'll explain it in a minute. 41 is of the type 4n plus 1. 43 is of the type 4n plus 3. And that just comes about because what's the distance between 40 and 41? 1. What's the distance between 40 and 43? Well, we have to add 3. So that's where that plus 1 and plus 3 comes from. All right. The 4n business is just saying that it's a multiple of 4. Okay? 44 is a multiple of 4. Okay? So that's where the 4n part comes from. And 43, let's divide it by, let's do the work over here. 43 divided by 4 goes in once, doesn't go in there, and we've got remainder 3. So there's another way to think about this. Okay? And of primes of this type, we can't draw them any other way except one row of 43. So the last part of this discussion, I'm going to move back to 41. And I want to show you something really interesting, because let's take 41, it's prime. Let's do the same thing. We're going to divide 41 by 4. It goes in once here and doesn't go in here, so put a 0, remainder 1. So we know 4 goes into 41 10 times and there's 1 left over. And we might have this mindset here that we can only construct primes as one row of something. Now, some primes we can do it something different here, which really is interesting. I find it super interesting. Let's put one block in the middle. Let's, because we knew 4 went in here 10 times, let's build this prime this way. Let's use 10 counters there. Let's use 10 here. Let's put 10 there. And let's put 10 there. So we've got 4 lots of 4 times 10 plus 1 equals 41. So it's really interesting and something to look out for, and a little test to see if what type of prime that we're dealing with can let us play and construct different arrangements of primes. There's more than that, but I think that's a this is a really good start to open your eyes, to get you looking out for these types of prime numbers. Mathematicians call them 4n plus 1 primes. Okay? So have a go at that. Play around with it. It's just play. It's just discussion, and we're learning something along the way. Thank you.